Jai Hind. Our today's topic is stack, a data structure which is linear in nature using linked list. Linked list is a collection of nodes. We store data in linked list in terms of nodes, in form of nodes, and these nodes are connected. These are linked in such a manner that we keep record of address of first node, and first node keep address of second node, second, third, and so on. So we are having a collection of nodes in this, and we know the address of first one, and if we want to go to a particular node, then we need to do the sequential access. Okay, so our discussion today is for stack using linked list. In this particular lecture, I am going to discuss this display, push and pop operation of stack using linked list. So let me start with the introduction first. What stack is? Stack is a data structure in which we implement last in, first out. What does it mean? It means if I have to store some data, let me say 10, 20, 30. So how will it be stored? We have to delete the one which is last inserted. So we call it a LIFO data structure, last in, first out. So as we have to do the deletion from the last point where we have just inserted, because it is last in, first out. So we need to keep track of that point. How do we maintain the record? Using top pointer. We have to maintain the record where we have just inserted. Okay. So initially we do not have anything in stack. Let me initiate it as null. Okay, so initially my top is null. There is no element here. Now what will happen? When I want to insert the first one, let me say 10. So what I'll do? I'll insert 10. Now my top pointer will point to this value, this location where 10 has been stored. Now what I have to insert? 20. Okay, so what we have to do? Last in, first out. So the top, we are talking about the top point from where we have just inserted, and if we need to delete, we will delete from that position only. So our next element is 20, because 20 is to be deleted first if we insert it first from 10. Okay, so what does it mean? We should put it on the top of 10. So what we will do? We will change the top to next location, and there we will put 20. Okay, now next element to be inserted is 30. Now 30, if we will delete here, 20 should be deleted, but if we insert 30, then 30 must be the first one that is to be deleted. Okay, what does it mean? It means top need to go to next location, and there we will insert 30. So top now will point to this. Now if we do deletion, so deletion will be from the last inserted point. Where is that? Top. So firstly what we will do? We will delete 30 and we'll go to next element. Now 20 will be deleted, and so on. So this is the way. So we can take it with a real example. If I am having a set of books and I have to put book on one another, so what will happen? I'll put one book, then another on that, then another on that, and if I have to take some book, firstly I will pick up from the top, then second, then third, and so on. So that is the stack. We can call it stack of books. Same way if we wash dishes, so if we arrange dishes, one dish will be put, then on the top of that second, then on the top of third, and so on. So this is the way to arrange the stack. Okay, so now let me consider that my stack is containing 3 elements. Firstly, I inserted 10, then I inserted 20, then I inserted 30. So I am having 3 elements and on the top it is 30. Okay. So now I have to implement it using linked list. So let us talk about linked list also here. Firstly, we have talked about the stack. Now I am talking about linked list. What is a linked list? Linked list is a collection of nodes. Each node contains some data. So let me consider here some data A. So I'll keep record of this in head. Then now I have to add data B. So I'll create a node, add to it B, and its address will be inserted here. Then another data that I will insert by creating the node, and then its address will be stored in this particular node. So now what the point is, it is storing the data in linear form. What is the linear relationship? One node is containing address of the next node. Okay, so if we have to traverse it, we will go it in sequential manner. Now what we are having a stack. Okay, how to implement the stack? For stack, we have to implement last in, first out. So when we have to implement last in, first out, so for that I just talked about what we maintain the top pointer. What does it mean? It means I am having some stack which is having data 10, 20, 30. So what I will have a node. In this I will insert 10. This will be my first node and its address I will store in top. As it is the first node created, so its next pointer will be null. We are talking about stack using linked list. Now we have to add 20. So what will happen for 20? We will create a node. We will insert 20 in that. Now it will be on top of this particular node. On top of this particular node means it will contain address of this node. So we will set here the top address. Top address, after setting the top address, it will point to this one. Now top will be changed. Now top is pointing to this. So on top I am having 30. Okay, now again let me take another element 30. So I'll create a node. In this address of top will be inserted and now top will point to this. Now see what we have done. The first node created was having the data 10, but we don't have any direct record of this. We will move sequentially to this. So this single pointer maintenance is helping us to maintain last in, first out data structure. That is our stack. So now let us consider the structure for this. So I have created a struct node in which one part is integer data and second is address to the same type of node. For example, here I am having 20 data and this pointer is containing address of this type of same type of node. So this is my data structure. Okay, now let us write the display function. So display will not return anything. So I am taking here display. What I have to display? The stack. So what is the node type of stack? That is struct node star top. We are writing a function to display the contents of stack. Okay. So now what is the scenario? Either it will have some data or it will be empty. So let us check that case. If top is null, if top is null, then print stack is empty. in that case stack will be empty. Else what is to be done? Else we have to display all the elements. So what is the element of at top? 30, then 20, then 10. Okay. So what we will do? Print. What we have to print? The data part of top. Here I am not using any particular language. I am writing in a pseudocode type of or just algorithm to display the concept. So print top data. Whatever is present at the top, that will be displayed here. Okay. Now when I'll do this, so top is pointing to this. Okay. So when I'll do, if top is null, no, it is not null. So what will happen? We will print the top data. Top ka data is 30. So it will get displayed. Okay. Now what we will do? Now we have to display 20 next time. So what we will do? Top is equal to top next. Now top will come to this. Now how long we have to do it? We have to do it for 30 display, then for 20, then 10. Where we have to stop? When top becomes null. Okay. So else while top is not equal to null. So what is happening? We are displaying the top data, then top is equal to top next. So we have come to this point. Now we will check top is null, no. So again it will print the top data, that is 20 now. Then it will do the top next. So now it will come to this node. Now again it will check if top is null, no, not null. So it will display the top data, which is 10 now. And then it will do the top is equal to top next, which is null here. So when we will do top while top not equal to null, so this condition will not be satisfied. So we will stop here. So what happened? Firstly 30 is displayed, then 20, then 10. The top element, then next, and then next. So this is our display function for the stack display data. Now we will write the push function. Okay. So what push will do? It will not return anything. Void push. What it will take? It will take the struct node type of data, because we are creating using linked list. Now the point is, when we do pushing, then top pointer changes. As top pointer changes, it means we don't want the top. We want address of top. Okay. So we will take the address of top. It is top address, not top. Why? Because top need to be changes and it has to get reflected in the main function or the calling function. And what we have to do? We have to add value. Let me call it val. So I have to put value. I have to put value, or I have to push value on the stack. The insertion in stack is called push. Okay. So what we are having now? We are having address of top. So that's why I have taken here double pointer. So what I'll do? What will be my first step? I'll take a temporary node, struct node star temp. So when I am having a stack, okay, let me call this is my stack, this is my top pointer. Now what could be the scenario? It may be the first node, or it may be the case that already we are having the some node, and on top of that we have to put it. So what we are doing? We are doing the first step. What is our first step? our first step is we need to create a node. Okay, so that's why I have taken a temporary variable start temp, and in temp what I'll do, I'll allocate memory, struct node star malloc size of struct node. So now this has been created. After creation of this, what happened? Its address is stored in temp. Now temp is pointing to this. Temp is pointing to this. So what we will do? Temp data will be set. What is temp data? That we have to push. What we have to push? Val. So I'll put here val. Okay, so whatever the data was, we are putting it here. Let me call the data was 10. So 10 has been set here. Now the point is, what will be the next of temp? Where to put temp? Push means put at the top. Okay, so put at the top means whatever was the top, that will become the second element. Okay, so what does it mean? It should contain the address of top. It should contain the address of top. So what does it mean? It means temp next will be the previous top. What is the previous top? This is our previous top. So now it is pointing to top. Okay, now what top will become? The last, now top will point to the latest inserted element. What is that? Latest pushed element, that is this temp. Okay, so it will take temp. So see what happened. Whatever was the top, that has been inserted here, whether it was null or some other entry. If it was null, then it will become the first node. If it was having some node address, then it will contain point to that. Now top is pointing to this. In top address, we have put the content of temp. So now the data has been pushed. We created a node, we put the value in that. Okay, then its next is taken as the last top element, and then this has been formed the top element. This is push operation. Pop operation. What pop will do? It will return the value which is present at top. So what we are having as input, struct node. Again, because we will delete from top, so top will get changed. So we need to create the top address. What need to be sent and collected here? That is the top address. Okay. Now what will happen? We will check, is there any element? It may be it may be the case that it is empty stack or some data is present. If it is empty, if star top address is null, okay, then return -1. -1 I am using here to show, to calling program that the stack is empty. Else, when stack is empty, we have to pop nothing. We don't have anything to pop from the stack. So else what I'll do, what I have to do, else means there are some elements. So some elements means I'm having an element, this node, then another node which is pointing to this, then another node which is pointing to this, and top is pointing to this. It means stack is not empty. So now what I need to do, I have to return this value. Okay, so I'll take a temporary variable int. Okay, in temp, what I'll take? Top data. What is top data? Top data here is 30. Okay, so, okay, please, there is a minor change. We don't have a top pointer here. We are having top address. So what we will have? We will have star top address data. Whatever was at top, that will be put in temp. Why we are taking it in temp? Because we have to return the popped value. Okay, so it will be temp is equal to star top address data. Now what we will do? We have taken this data. It is to be deleted. Okay, so it is to be deleted. It means it has to be stored somewhere, right? So one thing was struct node star f. What I am taking as f? What I am taking as f, which was to be freed. F is the node. Okay, so what f will have? F will have the address of this first node. Okay, so I am taking it as star top address. Its data, its address we have taken in F. There was another option. We do it first and then we take here F data. That is another option that we can have. What is that? Initially, firstly we take this address stored in F and then we take in temp F data. Okay, so what has been done till now? Its data I have stored somewhere in temp. What else I did? I put its address in F. Now F is also pointing to this. Top is pointing to this as well as F is pointing to this. Okay, now what will be there? Top is to be changed. Okay, so what will be there? Top will move to next location. Okay, so what does it mean? It means top will be F next. What is F? F is pointing to this. Top will be F next. So it means top is pointing to this. Top will be F next. Again, let me do the correction. We don't have top here. We have top address. So it will be star top address. Okay. This we need to take carefully. We have here we don't have top here, we have top address. So top address data is set in temp. So temp may we have 30. Then F I took this. Then I change the top. What is top? Top is now pointing to this. It means F's next. Okay. Now what we have to do? We have to return this value and the node which is stored in F, that is to be freed because now it has been popped and it is no more required. Okay, so what we will do? We will free the memory used by F and we will return. What we will return? The value. What is the value? 10. This is our value. So what we did? We checked whether the top is null. If top is null, then return -1. It means there is nothing to be deleted. Okay. Else, what we will do? We will take the data to be returned. So I took it in temp, which I am returning at last. Okay. So two steps are needed here. One, to take temp data, that is the value from the node to be returned, and another thing is the address of top in some other pointer so that can be freed. Okay, then top address is changed to next top. Okay, and then the memory has been freed and the value has been returned. So this is our pop function. Okay, so in this particular lecture we talked about stack, linked list, and then stack implementation using linked list, and in particular we have written the functions displaying the elements of the stack, push operation and pop operation of the stack. Thank you. Jai Hind.